that journey and our struggle to understand. In the pages that follow, you will be transported back to the tiniest fraction of a second after time began, and into the smallest nooks and crannies within the fabric of space. You will encounter observations in which seeing is truly believing, and theories that will challenge what you thought you knew about your existence. Sometimes those theories are not yet quite fully formed, or are in competition with one another, and some will ultimately find themselves on the scrap heap, supplanted by another theory that supports the evidence better. And again, that's okay. It's how the scientific method works. Consider the story presented here as a work in progress, a snapshot of the science on the route towards answering our greatest questions. After all, as the saying goes, the journey is often just as important as the destination. We join the story not at the beginning, but about 13.8 billion years later, in the summer of '64, in New Jersey, on the east coast of the United States, where two young astronomers were about to make the discovery of a lifetime. Chapter 1. The First Light in the Universe. A little bit of history. Like a tune that you just can't stop playing in your mind, the anomalous hum of radio static refused to go away. It was June 1964, and Arno Penzias and Robert Wilson didn't quite know what to make of their persistent radio hiss. The pair of radio astronomers were gearing up to use a large, anvil-shaped contraption called the Holmdel-Horn antenna. Their plan was to use it to study the strength of radio waves emanating from distant celestial objects, such as galaxies host to active black holes, or the expanding remnants of exploded stars. At the time, radio astronomy, that is, the observation of the universe at radio wavelengths, was still in its formative years. It was just 3 decades since Carl Jansky, a previous employee at Bell Labs, had made the first astronomical observations in radio waves, when he detected emissions coming from what we now know to be charged particles moving through powerful magnetic fields around the black hole at the center of our Milky Way galaxy. Jansky's discovery had opened up an entirely new astronomical frontier, one that Penzias and Wilson were eager to explore. Both astronomers were still young. Penzias just over 30, and Wilson still in his 20s, having graduated with a PhD in physics from the California Institute of Technology a few years earlier. At Caltech, Wilson had been taught by the brilliant but controversial Yorkshire-born astrophysicist Fred Hoyle, who at the time had been promoting his steady-state theory of an eternal universe in competition with the theory of the Big Bang. Penzias was already at Bell Labs and had recruited Wilson after getting to know him at various scientific conferences. The Holmdel-Horn had been designed and built a few years earlier by engineers at Bell Labs, with the intent of bouncing signals off the world's first crewed communication satellite, Echo 1. But now Penzias and Wilson were given permission to use it for radio astronomy instead. Although it wasn't the largest radio telescope in the world, it had an aperture of 6.1 meters, 20 feet, amounting to a total collecting area of 25 square meters, which is minuscule compared to the 4,560 square meters of the 76-meter Lowell telescope built in 1957 at Jodrell Bank in the UK's Cheshire countryside. It had several things going for it. One was that its horn-shaped design meant that its receivers were well sheltered from any terrestrial radio interference. Radio waves from space weren't going to be drowned out by the Billboard Hot 100. Second was that Penzias and Wilson believed that all sources of noise, i.e. radio interference from things like the